Okay, good morning. I have the pleasure of welcoming you here at this launch event of EASAC. I'm Wim van Saros. I'm one of the vice presidents of EASAC, and I'm a physicist from the Netherlands. EASAC stands for the European Academy's Scientific Advisory Council, an organization of European academies who work together to give science-based policy advice to Europe. We have 3 programs. First of all, the environmental program, under whose auspices the report A Sea of Change was written, an energy program, and a biosciences and public health program. EASAC is an independent organization supported by its member academies without outside funding. We are not a lobby organization for a particular interest group, a party, or a company. We simply strive to give our best advice on these topics based on the scientific insights of today. To do so, we establish working groups composed of the top scientific experts from Europe. We ask them to bring together all the existing evidence as it pertains to the chosen topic, and then report and advise based on these findings. A draft of every report is reviewed by a number of independent referees, and their comments are implemented in the final version. Today, we have the pleasure of launching the report, A Sea of Change. Europe's history and future are inextricably linked to the state of the Atlantic and the major circulation patterns that generates Europe's climate, define its ecosystems, and influence the weather that defines our agriculture and provides the energies that we now harvest from hydropower, wind, and even waves. Whether we can rely on historical patterns to continue, or whether they may change dramatically as the planet warms, is a critical question. This 2-year study from EASAC's scientists addresses these questions head-on and looks at the future threats and opportunities that arise from our knowledge of how the Atlantic is changing. This webinar will present the results of this work by the chair of the expert group, Tor Eldevik, and another member of the expert group, Martin Visbeck. We also welcome 2 important stakeholders to take part in the panel discussion. Pierre Kaltkin, a member of the European Parliament from France, and Annette Horrelman from DG Mare. Welcome to you all. A special welcome also to our former president, Thierry Courvaget, who took the initiative for this study and who joins us from his sailboat on the Atlantic. Please join us for a stimulating discussion covering everything from Europe's climate, fisheries, marine ecosystems, to supply of renewable energy. Before I give the floor to Tor Eldevik, a few housekeeping remarks. An important part of a webinar like this is that participants can ask questions to the speaker via the Q&A option, which you will find below in your Zoom panel. When you use this, please indicate clearly to whom you are asking a question. Panel members can answer these questions directly in writing in the Q&A during the meeting, but our moderator can also indicate that he will have a question discussed plenary by the panel. You can also comment on questions yourself. In addition, participants have access to the chat function, but please use it only in case there are technical issues, for instance, about the sound, not for the discussion about today's topic. And with that, I would like to open the webinar and ask Professor Tor Eldevik to take the screen. He is a professor of large-scale oceanography and decadal climate dynamics, and head of the department at the Geophysical Institute at the University of Bergen, and he's also associated with the Bjørknes Center for Climate Research in Bergen in Norway. Tor.
Thank you, and thank you EASAC and the Norwegian Academy of Science and Letters for commissioning this report and asking us in the expert group to provide the scientific basis. So coming into the European and the Atlantic realm as a Norwegian, there's maybe nothing that symbolizes this more than the codfish, the dried cod, the stoccafiso, the bacalao. And this over the centuries has maybe been our main connection to Europe and European trade. And if we think of this more in terms of marine resources in general, of course, the access to this fluctuates with the climatic conditions, the sustainability of the harvesting, and the degree of mutual collaboration and lack of conflicts throughout Europe or the world, if you like. And then, for example, Bergen, where I'm from, we are literally built on this fish, including our connection with Europe through the Hanseatic Society. So I will just go very briefly to the scientific review we did for the report. So you'll recognize very much what I say if you just look at the summary, I believe, and the first chapters after there. I will point shortly to the policy issues, but this Professor Visbeck and others will follow up more closely on afterwards. So just looking at the figure to the right, you can already appreciate what blessing it is to be in the Atlantic realm. You see the Gulf Stream, the North Atlantic Drift, and even warm waters going all the way through to the Arctic, making even Norway's coast ice-free. So we see at the eastern side, it's a much more temperate climate, including on the continents, than on the Western Greenland, North American side. So being in the Atlantic realm is generally a good thing. So the report, or at least the scientific basis, is broadly about 4 things: where we're at, climatically and so on, what we must avoid going into the future, what we must anyway prepare for going into the future, and then trying also not only to look at this 2100 climate change, but taking more the immediate and practical future, what we can further benefit from. And just looking at gross numbers of the marine related and largely Atlantic related economy, and here's the blue economy of the European Union, you see coastal tourism, shipbuilding, marine renewable energy, etc. And these are numbers in millions of euros. So these range from 1 billion to almost 100 billion euros in gross values added. So in the most mundane sense, this is very important. Okay, so where are we at now in the year 21? So order of global mean change approximately since the 1900s is that we have observed the global sea surface temperature to rise about 1 degree. And when water warms, it expands, and together with ice melting on land, we have a sea level rise of about 15 meters. But it's not homogeneous. It's extremely heterogeneously distributed around the globe. With the CO2, much of this goes into the ocean, making it more acidic, and we have ocean acidification, presently estimated to be 1/10 of a pH unit. And maybe this is the more or the most uncertain part we're dealing with in the report, because in the natural system, there's large spatial and seasonal variability to it, and it's relatively, compared to the other, particularly sea surface temperature, lacking in observations. And you can have a feeling for how the observations have developed and how we benefited from them through the decades and centuries just by looking at the figure to the right. There's large uncertainties coming from the 1900s, and then there's a period of war. And then when you see the satellites come up in the 70s, we are very certain in what we observe. We can observe the ocean surface at the same time globally. Then we look to the longish term future. We have the eye on the year 2100. And if we remain in a high emission scenario, what we used to call a business as usual, we could see a global warming of the sea surface temperature of about 4 degrees since the pre-industrial. Sea level rise, more uncertain, particularly because of what will happen with the ice on land, but an estimate is between 0.5 and 2 meter sea level rise. In the figure to the right, you see the estimate in blue, what will be the flooded areas in the North Sea region with 1 meter sea level rise. The black dots are major population areas. Particularly, we point to in the report that it has been found that one century-like exceptional storm floods, they can become annual under this scenario, which we don't want to be. Ocean acidification will quadruple, but keep in mind that this is a logarithmic scale, so unit increase is a tenfold. And then, even though much is uncertain about ocean acidification, with this change in the system, we start to compete with what is there of natural contrast. And this is, we know, is not good for the ecosystem and so on. What we must anyway prepare for when we go where we should go, the more Paris Agreement-like future, then there is, in lack of a better word, the more moderate sea surface temperature warming of 2 degrees since the pre-industrial. We must still be able to tackle a sea level rise up to 1 meter. The risk of these storm floods that I was talking about for Europe, that is substantially reduced, but still we talk about the 100-year floods could become about every 5th year in average. Ocean acidification, more moderate, but still substantial. But given the many unknowns there, it is largely unknown the specific consequences of that. If I go a little bit back to what we must avoid, because what is maybe most in public or largely in public immediate attention is the symbol of the Gulf Stream and whether that could be collapsing. And well, I think the short answer, at least in the short term, the answer is no. And there's several issues to take into account there. First of all, what we normally or often discuss in the scientific literature and then is disseminated into the public domain is what is concerned with the so-called Atlantic meridional overturning circulation, the AMOC, the warm water going northwards in the surface and the net flow southwards at depth. This is not synonymous to the horizontal circulation of the Gulf Stream. This is important to keep in mind. Secondly, this overturning circulation, our best estimate is still that this will weaken because there is less poleward heat transport under global warming towards the Arctic by 10 to 30% by 2100, given the scenario. However, there's nuances to this because as the planet keeps warming, the Arctic particularly so, Atlantic water penetrates further and further north. So locally, more heat goes to the north, and the northernmost branch of this system is can actually be expected to strengthen. One of the main observational efforts of the community the last 15, 20 years have been the quantification or observation of this overturning system. And you see a time series of that since 2005 down to the right. And you can see periods of decrease, increase, and generally a lot of ups and downs. And this we point to in our report and our assessment that presently trend cannot be robustly distinguished from the interannual to decadal variability. So if we for the remaining, or at least for the next few slides, can keep our attention to this variable nature of things and not necessarily where things are going by 2100, let's get back to the cod, or in general, the harvesting of resources in the Atlantic domain and what we eventually can further benefit from. So in this beautiful and temperate Atlantic domain of ours that moves slowly, there are cold and warm phases, there are the westerlies blowing in over Europe that fluctuates as well. It reflects over the continent as you see in the figure to the right with the simplistic color scale. And these are the phases of mild and cold and mild winters. So over much of continental Europe, these fluctuates on a 7-ish year timescale. This is related to the fluctuations of the westerlies coming in from the Atlantic, the so-called North Atlantic oscillations. When we look at Scandinavia in red and Iberia and parts of the UK in blue, these are more directly related to the swinging state of the ocean itself. There's a 15-year life cycle, which you will also see reflected in the catchment of cod for Scandinavia. And there's more this multi-decadal, so-called Atlantic multi-decadal oscillation that's reflected in the winters of the UK and Iberia. Imagine then if we were able to predict this with an outlook horizon of 1 to 10 to 20 years. Very much of what we do with respect to natural resources, fisheries, agriculture, tourism, even the harvesting of renewable energy relates closely to this. And as an example, hydropower production is still the main renewable of Europe. It's soon to be passed, or maybe has already this year been passed by wind. But anyway, so here we see for Norway in red, the annual hydropower production, and overlaid here is the strength of the westerlies coming in. And it's via the precipitation then falling on the rest of us. But think, there's millions, billions of Europe's fluctuating here. Imagine the potential for planning and so on if we could harvest on this. And also on the consumer side, if we could predict the coldness or the mildness of winters, we could have a handle on the probabilities involved in that as well. So to round off, and also to the right, I must remember to thank all the members of our expert group. Thank you for making this possible. Here are some policy issues, research needs from the top of my head, and also consistent with the report, but Professor Visbeck and others will dig further into this. So what is a little bit muted or just very implicit in the report is that we're extremely blessed with an observational and later on modeling capabilities. We have had decades of science-based fisheries, for example, in Europe, with a lot of observations. There was a Cold War with a lot of observations and so on. So to maintain and increase this, to sustain our knowledge and our monitoring is, of course, very important. As I just showed, there's an untapped potential for climate forecasts, fisheries, renewable energy, agriculture, tourism, etc. So this is literally the fluctuation of resources in the Atlantic realm. No surprise for the climate change future. Please remain by the Paris Agreement. And irrespective of scenario, and I believe Martin Visbeck will get deeper into this, for example, sea level rise and ocean acidification, much is still unknown. For the low likelihood, high impact change, for example, AMOC, well, not collapse, but still a strong weakening. This remains a risk and needs monitoring and further consideration. But also we need to be aware of the less spectacular, what just happens on the gradual change we're in. Increment by increment, we can still cross thresholds. And this is what in the Horizon 2020 Comfort project has been termed the quiet crossing of tipping points. So we need to have 2 or 3 or even 4 thoughts in our head at the same time. So thank you. This was my brief tour through what we've been discussing in our group and what EASAC has helped us formulate in this report. You're muted, Wim.
So thank you, Tor. We'll now move on to Martin Visbeck, who is also a member of the working group, and he will discuss the policy implications of this report. Martin is a physical oceanographer, a professor at Kiel University and head of the research unit Physical Oceanography at the Geomar Helmholtz Center for Ocean Research in Kiel. Martin.
Thank you, Wim. Thank you, EASAC, for allowing me to take part in this wonderful assessment. I think science advice is really important. And what I like to do is to really continue a little bit from Tor Eldevik's introduction to the science of the report and bring it back to the policy end and see what's there. There's a couple of points that we make in the report that speak to some of the issues that we just heard. So the key knowledge gaps on the one hand that also should inform policymakers. On the one hand, and I'll give you some more concrete example in a moment, we really want to strengthen our abilities to detect the early warnings of these potential high impact tipping points that Tor just mentioned, for example, around the overturning circulation of some of the shifts in the circulation regimes. And I think we're not quite there yet where we want to be, and we need collectively to sort of step up our efforts in that arena. I'll speak more about that. There's a need to assess the local magnitudes and timings for sea level rise, and I'll show you a figure on that. Certainly the regional trends of ocean acidification and its effect on local ecosystems is still very much in the research realm, although we made enough progress to give some advice to policymakers. And certainly the development of the linkage between the oceanic changes in European weather and the potential predictability that would allow us to more and better foreshadow the evolutions for the Atlantic system and their impact on the European region, weather and alike is certainly interesting. So this report in many ways provides a lot of science basis for the development of future policies, both within the Commission and the European Parliament, but also with our European nations and governments. So, colleagues, on the other hand, this report doesn't stand on its own. It builds on academic research at the various academies that are part of the EASAC, but it also builds on international activities that we took some advantage of. For example, just 2 years ago, a recent report from the Intergovernmental Panel for Climate Change, the Ocean and Cryosphere and a Changing Climate came out that really speaks and gives more numbers around the issues that Tor just summarized about change in the ocean condition, about the warming, circulation change, but also the cryosphere, melting of the ice and the like. So we heavily, certainly contributed to and depended from that. I also want to highlight another piece of science advice that came from the Commission, Food from the Oceans. And I think it very much looks into the issue, how important food generation, mariculture, fishing, aquaculture is for the Europeans and how that is intricately linked to the climate. I'll give you an example in a moment. I also want to mention the report that just came out, I think 2 weeks ago, or maybe 4 weeks ago, about the transformations needed to a sustainable ocean economy from the high-level panel on sustainable ocean economy. Very interesting report, a global group, a lot of European actors led by Erna Solberg, the Prime Minister from Norway. And last but not least, the policy brief that we released last week is about sustaining the in situ ocean observing system in the age of digital ocean. And I will make reference to some of these additional works in the context of our report. So let me come back to this issue that we just heard about the overturning circulation. As Tor was mentioning, the overturning circulation is part of the heat transport that impacts in particular also the European region, but also the whole northern hemisphere, in particular in the Atlantic sector. It is an area that has been heavily researched, the heat transport and its variability. Tor mentioned the connectivity to fish, there's the connectivity to climate, there's the connectivity to navigation, the ice, think of the Titanic as an example. That was a very year with a lot of icebergs in the North Atlantic. So these waxing and waning of the overturning circulation and the associated climate has been with us a lot. And yet we will have to say we can hardly fully observe it. There's been some recent efforts that the scientific community could put forward, and we haven't fully understood the last 50 years of evolution. There's still some scientific debate on whether it went up or down, and Tor give us the latest evidence of the last 20 years, which shows more that the variability dominates, and yet we are quite certain from the scenarios that we have that this circulation will slow down. But from a policy point of view, I think we need your support about observing systems, about the ability to use the best science to really understand that fundamental heat transport system for Europe. And unfortunately, we understand a lot already, but we don't have that warning system in place that gives us sort of a week-to-week and even from a forecast point of view an ability to say exactly what the overturning is doing. So this is still an area where observing systems are making progress, but we're not quite there yet. And I think it is about time for the European leaders to think about how can we come to a more sustained observing system like the same that we have for weather and for climate on land. The next point that Tor touched upon is sea level rise. Now, sea level rise, and we gave two graphics. I'm going to speak to the middle one more time. These areas here are shown what would happen for a 1 meter sea level rise if there were no defenses. Now, we do have defenses. We have dikes in all of these regions. So don't take this as a chart that says this is what the world will look like with 1 meter sea level rise. It will not look like this. But what it would show you if our defenses break, this is what the world would look like. The real challenges for countries like the Netherlands, Germany, Denmark, UK, and the like, how do we deal with the protection of our impacts with sea level rise? And the first question they would have is, okay, the Intergovernmental Panel for Climate Change here, that report gives the global number. But any defense decisions have to be done on regional numbers and local numbers. So there I want to point to you to the figure on the left. And the figure on the left shows you the net sea level rise at a local level since 1970. And what you see here is that in the North Sea, for example, sea level is going up by roughly the global rate, while when you go to the Northern Baltic, sea level actually is still declining. And that is because the land is still rising from the last ice age where the glaciers went away, and now we have still uplift. So at a very local level, these trends are often much more complex, and it's even more complex around Greenland with the massive losses of mass from the glaciers. So, and the science is making progress to understand and quantify the local sea level rise, but the uncertainty is actually much higher there at the local level than it is for the global level. But it's the local level that is important for action. And this report makes the point that sea level rise is a significant challenge for our major infrastructures also in Europe. And we do have to prepare for a mean sea level rise of roughly 1 meter for at least the North Sea regions here. And what's the best defense strategy is a lot discussed. Is it about building dikes? Is it about building sandbars? So to reduce the effect of storm surges during these storm surge flooding events that we're more accustomed to. So these are very technical and interesting issues, but I would say the report makes a very clear case that the policy response to that report is needed. And I'm not convinced that all the regions are taking these threats of sea level rise seriously enough. And the last point, and Tor mentioned that very clearly, even under the most ambitious mitigation scenario, let's say we hit the 1.5 target, which is very unlikely, but even if we would still get at least 60 centimeter more sea level rise. And if we don't get that, we get 1 meter or maybe more. So even under the strongest mitigation scenarios, we still have to adapt to sea level rise. And that is a very important point to be recognized by our policymakers, in particular in Europe, but not only. The next issue is if you want to reduce some of the impact, it is about mitigation. And I think we make the point in the report that renewable energies, in particular also as they pertain to opportunities in the ocean space, are there. The table here gives you some numbers of the potential to install wind power in European country in gigawatt, the capacities here, you see it for the various European countries. It's actually quite a bit. And as Tor was saying, it is quickly becoming the largest renewable energy source. It used to be hydropower, but now wind power is taking over. And in particular, the offshore installations are gaining a lot of momentum. It is from a logistical point of view, not so easy, but you're not so much competing with land use issues. But they also have the opportunity to be co-located with other interventions, for example, mariculture installations on the one hand, but they themselves then depend on the climate as it moves forward. So it's important to understand if you install certain wind installations, certain regions, how often can they produce? What is the opportunity if the NAO switches the climate modes, goes one way or another? Is there a risk to be thought about? But the renewable energy is going to be one of the solutions to the climate challenge, and we make that point. And the ocean has a part to it. There's other areas. high-level committee on the ocean economy suggested that all of the activities around carbon, if the ocean can contribute about 30% to the CO2 emission reduction needed to hit the Paris Agreement. So that's quite a bit for the ocean realm, and we talked to that. Tor mentioned a lot the other challenge. If you go to renewable, be it hydro, be it wind or others, they will depend on the state of the climate, and having an ability to in real time assess what it is, short-term forecasting for load balancing, but long-term forecasting for site locations is really important. So there is a policy dimension to understanding the climate system of the Atlantic, the circulation around it, to really help with our renewable energy agenda here. We then touched on issues around ecosystem-based management and what the Atlantic sector and the role of understanding circulation and the oceanography and the biogeochemistry where there is. And it really presents some challenges for example, European policies, because some of these issues cut across various directives in the EU or ministries in our member states countries. So on the one hand, so how do we deal with the interaction between species, habitats, and ecological processes and work towards a complete realization of the good environmental standards under the Marine Strategy Framework Directive? And that is something that really brings together climate science, ecosystem science, biogeochemistry of the ocean with those who use the ocean, for example, in the fisheries. So we really wanted to quantify better the marine species interactions and how they adapt to changing conditions in the marine environment, including benthic pelagic coupling. But here I'll give you the example that Tor mentioned. As the climate warms, the ocean warms. As the ocean warms, we will see that marine species react to this by on average migrating towards to the more temperate climate that they're used to. And how does that play into our management strategies about protection areas, about fishing rights and the like? Developing an end-to-end integrated models that characterize the socioeconomic benefits from the sea, the supporting ecosystem and biodiversity, and the human and natural pressures that threaten them. So here the plea in the report is very clear. We want to have an Earth system approach, an ocean system approach that combines the climate understanding that we presented, the ecosystem understanding, with the use that we want to do with the ocean, and then the value, the socioeconomic value that is characterized from it. Sometimes we call this system digital twins of the environment that really look at the whole system and allow us to optimize our intervention. So this is a clear need from the policies together with the Academy's work moving forward. And certainly that depends on modeling capabilities that Tor mentioned, observing systems. And last but not least, we will need to build scenarios that explore future responses of the marine ecosystem under anthropogenic and natural forcing that helps to control and the limits of ecosystem resilience. So this is really very much about how resilient is the marine ecosystem, how much stress will it become from anthropogenic interventions, and how are they comparing to the natural forcing of the systems. And I think we're making some progress on that, but the resilience angle is so important from the policy point of view, because the policies are about ensuring resilience. It's the resilience of societies what is most important. The scientists want to understand the Earth system, but connecting that with resilience is a great way to go forward. So I'm going to give you one last example here, and then we can sum up. The effects on marine biodiversity and fisheries. So the change of ocean temperature, circulation, upwelling, and the associated effects on water properties do affect wide areas in the ocean. And here we gave a nice graph that just shows you how these various fish stocks that are fished have changed under changing environmental conditions, and some go up and some go down. And if you're thinking about fisheries policies, I think it is extremely important to take into account the boundary conditions within which the fish stocks are operating and how they are changing because of climate change, because of human interventions. And I think to bring all of these things together, this is the integrated science that we're promoting here. And I think it resonates very well, I think, for many of the policy directives that we're seeing at the European level, that this bridging across the various directorates and working together, for example, on food security from the ocean, by really also taking into account the environmental forcings. It is not just an issue about those who are responsible of the fisheries directly. My last point is that the visibility of the ocean in policy and also in policy advice is heightening. We just this year started the UN Decade of Ocean Science for Sustainable Development, where collectively across the so-called ocean family, we really advance the science that we need for the ocean that we want. That means, how can we take advantage of the academic sciences across the academies to make informed decisions about sustainable development in the ocean context? And I think our report, A Sea of Change, European Future in the Atlantic Realm, is a great contribution to the ocean decade, and we expect many more studies like that, inputs from the academic community towards a more sustainable human-ocean interaction. I think the UN Decade of Ocean Science for Sustainable Development is an excellent frame for that. And like Tor, I think we would like to really acknowledge our colleagues here and the academies that made this report possible. And also from my end, I want to thank the European Academy's Science Advisory Council, EASAC, for supporting us. And I hope that we can be impactful with this report and really heightening the awareness of the importance of the ocean, the climate dimension, and the changes in the ocean system towards our human-ocean relationships. Thank you very much.
Thank you very much, Martin. We're very fortunate that two people have accepted our invitation to give their own reflections and comment on the report. The first is Pierre Kanskin from France. He is a member of the European Parliament, and he himself is an oceanographer. His party he's with the Renew Europe group, and within the European Parliament, he's also the chair of the Committee on Fisheries. Pierre, may I invite you to take the screen?
Sure, thank you very much, and thank you for Professor Visbeck and Professor Eldevik. I would like, of course, to thank EASAC for the organization of such an event, and its president, Wim Santarlos, for the invitation. I'm very honored, I must confess, to be invited this morning because we are addressing two topics that are really important to me. The first one is the dialogue between science and policymaker. You've just mentioned it. Before being a member of the European Parliament, I'm still an oceanographer, even if I do not continue my work on that. I defended my PhD thesis. It was a little bit more than 10 years ago in marine sciences on the topic carbon, oxygen, and nutrient balance in the Northeast Atlantic. So you perfectly understand that the continuing dialogue between science and policymaker is key to achieve the best policies. What we can see in this report is that the expert group offers some thoughts on the policy areas, and this type of initiative is what we need more in order to regulate in the best way. The second topic, of course, which is central in this report and really important to me, is the Atlantic Ocean. I live in Brest. Brest is a port on the Atlantic Ocean. And in the region where I live, we are confronted directly to all what we are talking about. Fishery, sea level rise, and all these questions that we have on climate change. Things are changing, pollution might occur. So all these things, I can live with them daily. Well, when I'm Brest, of course, if I may say so. As you understand, it has been a topic that I have researched for many years, and now what's interesting is that we are zooming on what it does mean for us in the future. So we know that Atlantic is changing, global changing. Being a scientist, I must confess, helps me to realize how this is true, because we have heard about the ocean changing, current lowering, speeding up, or changing winds, temperature rising, sea level rising, changing in the marine environment. But we know that all these things, and this has been said, sorry, we have to make connections between all these questions. And you have you have talked about the global thermal circulation. This is a huge question. The conclusion is that the probability is quite low, but we are just talking about climate on Earth, because we know that global thermal circulation is mainly driven by what happens in the Atlantic Ocean. So we are at the forefront of understanding precisely what will happen on Earth, on the climate. So what has been done in terms of policy making, if I may come back to policy? I think that you've said that the importance of managing the ocean is in a more sustainable manner has been widely recognized at every level, national, European, global. Even if I heard from you that when you talk about sea level rise, sometimes regions doesn't seem to take care of that. But we have to understand that if you take care of it, you will have to pay. And the amounts are so huge that one city, one coastal community cannot afford that. So we will have to think together. And once more, it is the together word which is important. On the global level, to come back to something wider, the United States enshrined ocean preservation as a sustainable development goals and created the UN Decades of Ocean Science for Sustainable Development. At the European level, the increased recognition of the importance of our oceans and seas can be seen in the blue economy and in the Green Deal initiative. In January 2020, a couple of members of the European Parliament from my political group, you've mentioned it, Renew Europe, published a call for a Green-Blue Deal with Commissioner Sinkevicius, who's the Commissioner for Environment, Ocean and Fishery. A bit over a month ago, on the 17th of May, the European Commission adopted a communication on a new approach for a sustainable blue economy in the EU, which name is a Green Recovery for Blue Economy. This strategy sets out a detailed agenda for the sector to transition from what is called blue growth to a sustainable blue economy, replacing unchecked expansion with clean, climate-proof and sustainable activity. So this must have concrete policy consequences. And I'm happy to hear some comments of you, especially on the common fishery policy. This policy is not yet a real ecosystem approach. It is said to be an ecosystemic approach in the regulation, but it is not yet. For the Fishery Committee, the main tool that we will have in the upcoming month is the revision, the evaluation. The Commission says the evaluation. We would like to have a revision of the common fishery policy. It is the opportunity for me to include a real ecosystemic approach. This is an urgent need to integrate a common ecosystemic approach across all components of marine policy, and to ensure that initiatives under the Blue Growth Agenda are compatible with protecting biodiversity and marine and coastal ecosystem, and taking into account climate change and its consequences. Once more, we have to link all these questions. Of course, I want to say one more, that we need more funding for research. I've just said that for some questions, we are at the forefront of the global change, on the analysis of the global change. So improving our knowledge of the ocean and its ecosystem is key in supporting the development of a sustainable blue economy. The communication on a new approach for a sustainable blue economy in the EU that was just published dedicates a paragraph to the role of research and innovation. As of now, the European Union has many funds and initiatives. I will say Horizon Europe, the European Maritime Fishery and Aquaculture Fund, the MFAF, the new Interregional Innovation Investment Initiative, and the EU Climate Action Innovation Fund. This is important. Maritime and marine research and innovation are crucial for achieving the EU ambition to become climate neutral by 2050. and for protecting and restoring marine ecosystem, and for making the blue economy a laboratory driving sustainable innovation forward. One example of this is the mission Healthy Ocean, Seas, Coastal and Inland Waters, led by Pascal Lamy, allows the ocean to be at the center of Horizon Europe as one of the 5 main topics chosen for the coming 7 years. The Starfish, because it is its name, mission was the result of this process with 5 main findings, like the 5 arms of the starfish. The first is filling the knowledge gap, then zero pollution. Third is revamping governance. Fourth is decarbonizing our oceans, seas and waters. And 5, regenerating marine and freshwater ecosystem. This is, I think, at the core of our work. So we have now to look ahead. The Atlantic is going to be scrutinized for many more years. On the shores of the Atlantic, there is, of course, America and Europe. But at the very ends of this ocean, there's the Antarctic and the Arctic. These 2 regions are becoming increasingly important issues for the Atlantic and for Europe. I couldn't continue for a very long time to talk on the Atlantic Ocean, but I will stop now. I think that the time is now over for me. I will continue to fight for this question from inside the Parliament. Thank you for your attention and for the time.
Thank you very much for your comments and remarks. And surely some of these issues will come back in the panel discussion. I would like to finally invite Annette Horrelman, who is with DG Mare, where she is the head of unit scientific advice and data collection, overseeing the fishery policies in the Atlantic, the North Sea, the Baltic, and the outermost regions. Annette, may I ask you to take the screen?
Yes, thank you very much. I would also, of course, like to start by thanking very much the authors of this report, all the scientists who worked on it, and also the organizers of this seminar. I think it's a very important occasion to discuss the impact of science and scientific advice on the European policies related to the oceans. So the report, of course, covers a very large spectrum of issues. It talks about biological processes such as the sea surface temperature and the ocean circulation. It also talks about the impacts on marine biodiversity, including the shifts in population ranges and distributions in species and stocks, which are, of course, a very relevant issue for us in terms of the fisheries policy. And it outlines the policy challenges, the policy fallout, the policy responses that are associated with these processes and impacts. Now, since I'm here from the policy side, from the policy making side, I will of course concentrate mostly on this third aspect. So what does this mean for us, for our policies, and where do we actually search for input from science? Where do we need more advice, and where are also the areas where we are already having a very good look at what science can bring to us here? Since I'm in the unit, as Wim has already said, that deals with fisheries science and data, my intervention will certainly have a bias towards these fisheries issues, although I will do my best to also look at the interlinkages that are there, of course, with other areas. I would like to start by saying that the report clearly shows that all of these processes in the oceans are interconnected. They are extremely complex. One thing influences the others. The second thing is that, of course, we do not have complete full information. Many things may not happen exactly as we expect them to happen. There are really big margins of uncertainty. But one thing that is clear is that neither the complexity of the topic nor the uncertainties that we have can be a reason not to act and to delay the response. I think that is also extremely clear from the science. I can say that at the European level, the need to react has been very clearly recognized. MEP Karleskind has also made the same observation in his intervention. So one thing that is a very clear sign of that is indeed the European Green Deal. Again, it has been mentioned already, with its very many actions that are a clear signal that European politics has understood this need to act. What we need, of course, to implement this European Green Deal properly is a very strong evidence-based base, and therefore we really need the support of science and research to do this properly. And I would like to stress that the common fisheries policy is actually a policy that is very well positioned to do that, because also, as Tor Eldevik has already said in his intervention, the common fisheries policy is a really strongly science-based policy since decades. I would dare to say that few policies at European level, at national level, at worldwide are really science-based to this degree. And that means, of course, that in those who deal with the CFP from every direction, administrators, politicians, stakeholders on all sides are very used to respecting science, looking at science, taking science very seriously, making policy with science, and also being, and that's going to be one of the topics that I will come back to, being very pragmatic also about how to actually use the science in policy. One of the main principles of the common fisheries policy is to define management measures based on the best available scientific advice. And there is a whole fisheries data and science operators that is behind this principle, which I know very well, because indeed I had the unit that is doing a lot of this organization of this whole operators in the European Union. I believe that other policies that deal with oceans, deal with natural resources, with environmental issues, but really any policy can learn also from this very strong science base of the fisheries policy. And I think we need more policies to take science extremely seriously and operationalize science in their implementation. I have already mentioned that the Green Deal is a very big policy priority, of course, at the moment for the decades to come, I would say. The biodiversity strategy within the Green Deal is designed to ensure that the EU can better contribute to conservation efforts, including by increasing the effective management and coverage of protected areas at land and sea. And one element of this is the expansion of the current marine protected areas to 30% of the oceans, which is, of course, a very ambitious move. And what is very important in this move, which is also underlined in your report as one action, is of course that it's important that this implementation of the marine protected areas does not result in just the so-called paper parks. They are there on paper, but they don't do anything in reality for the biodiversity. And therefore, again, we need a good science base to do that properly. This is why, and now I come to the concrete examples that I had already announced to you. This is why we covered in our this year's seminar on fisheries science, which is an annual event that we do from DG Mare, with scientists to talk about topical issues. So we organized this seminar this year about marine protected areas, with the question on how can marine protected areas be a tool that also is good and is useful for fishers. And we looked at the question together with the scientists, what are the enabling conditions that can make MPAs work for fisheries? And we looked at the successful case study in Italy of a marine protected area. The main outcomes of this, if I can just summarize it really in a nutshell, is that marine protected areas need very clear conservation objectives, and they need management measures that are based on the best available scientific advice. So here again, clear call to the science and the need to cooperate. And the second element, which is really more on the socio-economic scale, which I would also like to bring in, because of course for the policy response actually to the challenges, that's very important. The second conclusion was that it's really important to involve all stakeholders in the process of planning and implementing marine protected areas. MPAs work best where fishers and other stakeholders are involved in their design and management. I would also like to come briefly to the approaches to fisheries management. This has been mentioned in the report. It has been mentioned in the various interventions that came before me. So indeed, for fisheries management, the Commission follows a precautionary approach, which requires a continuous provision and review of the scientific evidence. We work with organizations, scientific bodies such as ICES, the International Council for the Exploration of the Sea, or and the STCF, our Scientific, Technical and Economic Committee for Fisheries. In practice, the practical, I would say, measure that guides a lot of the fisheries management is the maximum sustainable yield approach in the EU, but also internationally, to a very large extent. With this approach, the CFP has been very successful in managing a reduction in the average fishing mortality. In particular in the Northeast Atlantic. We will not, I think, talk so much about the Mediterranean, as this was also not so much in the report. Of course, there are substantially more problems. The MSY concept is certainly not a simple measure, but it is, of course, a simplified approach that really looks at a single species stock assessment. As it has been mentioned before, it is certainly very desirable to come to a more ecosystem approach to managing fisheries. An approach that takes into account more of the habitat, more of the overall bigger changes in the marine environment, the species interactions, and so on. The ecosystem-based approach is already enshrined in the CFP. The CFP shall implement the ecosystem-based approach to fisheries management. It says in the basic regulation, as to ensure that negative impacts on fishing activities are minimized. So the legal basis is there, but the aim is a very steep aim. Also because, first of all, of course, more sophisticated data demanding models which take into account things like species interactions and environmental conditions are not easy to implement. They have high data needs. The outcomes may be have a lot of insecurities that can then also be criticized rightfully by stakeholders from all directions. What is the big challenge is to really think of how we can operationalize an ecosystem-based approach to really make it into a possibility for the day-to-day management of the fisheries. We have launched, to come back to my examples, we have launched recently a scientific advice study. We have, under the European Maritime and Fisheries Fund, the possibility to launch scientific advice studies, which is looking exactly at this question. Which EU fisheries management practices and measures can we see that are already implemented now and can be understood as actually being ecosystem-based approaches to fisheries management, or at least display elements that we could characterize? Because as the report also makes clear in the one text box on the ecosystem-based management, it's not even so easy to define what exactly it is. There are different approaches to this. There are different interpretations of this. So the practical aspect of this is very challenging. I will close here. I could still talk about many things, like, for example, data, which also we deal a lot with in my unit. And of course, the question of big data, what data do we need? What possibilities do we have to collect this big data is something that we may still want to touch on in the discussion. And Martin Visbeck has also mentioned data already. Also interesting would be to talk about the Arctic and what is happening there. We've also been involved in some research projects there. And of course, the whole question of going beyond fisheries and the use of the sea space. The ocean is big, but the part that everybody wants to use for their activities is, of course, actually relatively small. And then we come into a situation where there is a lot of competition. Wind parks, fisheries, aquaculture or mariculture has already been mentioned. So these are all extremely interesting aspects, but we don't have enough time, or at least now I don't have enough time to go into all of these details. So I would like to close by again thanking you for the recommendations. I would like to underline again that for us as policymakers, of course, very operational recommendations are always very useful. But on the other hand, also I would like to underline that we also realize that science and research cannot always be just geared to a particular policy question. We must also have research that is really just research and is not designed to be there for policymakers to kind of take and apply directly. And I think one of the things that maybe we can also come back to in the discussion is how do we make the link between the big research and the actual implementability of it to the EU policies like the common fisheries policy. So thank you very much.
Thank you very much, Ms. Hurlman. And I'm sure that indeed many of these issues will come back in a discussion. I will now hand over to Mike Norton, who is the Program Director for the Environmental Program at EASAC, and he is the driving force behind all the reports that EASAC is writing in the Environmental Program. Mike.
Thank you, Wim, and hello, everyone. As Wim said, I'm the Environment Director for EASAC, and I had the pleasure of working with Tor and Martin and the other expert group members on the report, and in particular in developing the implications of the science for European policy, which is really what EASAC is all about. You will have heard from Tor and Martin how broad the implications are of changes to Atlantic circulation patterns. And you've also had some very helpful and relevant comments from Pierre Karlskind and Annette Hurlman. So thank you all for agreeing to join the discussion. One of the starting points for the report itself was to explore to what extent we were at risk of a significant weakening of the overturning circulation. And you will have seen from our analysis that we're still unclear to what extent there is a trend towards the IPCC's forecast of a weakening by the end of the century. We now do have some impressive monitoring installed, giving us real-time data, and are getting better at looking for signs of significant weakening. And as Martin and Tor emphasised, we need to continue this work and refine further due to the importance of this circulation, not just on the European regional climate, but on much wider impacts extending as far as Asia, and also influence the heat balance processes affecting the whole planet. So that, I think, is something on which everyone has a consensus. But a major role of our report was to look beyond that single issue, public issue, and to bring into focus the wide range of mechanisms through which the Atlantic affects important European resources. Temperature and circulation trends affect the primary production that underpins the marine ecosystems and the nature and distribution of commercially important species. We've heard a lot about that. The seas are becoming more acid and the sea level is rising. And that's at the same time as we're looking to the seas for increasing amounts of renewable energy and potentially other resources. So we have quite a few items on which the panel could discuss further in the limited time remaining. So without further ado, I'd like to just follow on from the last comments on the importance of ecosystem-based fisheries management, which is contrasted with the ability of people to reach a consensus and actually develop something which can be given the importance it is assumed to have within several European directives. And the question really I put to the panel, perhaps Martin might start, is whether there are any scientific resources which are not yet tapped into trying to solve this problem, and whether there is some approach which might also strengthen the work of ICES and all the other links which the Commission has, and try and bring this. For instance, is there more to be learnt from countries which have developed this and applied this in a more quantitative manner, whether that's New Zealand or Norway or maybe some parts of the USA?
Well, thanks, Michael, for the question. And indeed, I would first agree very much with the intervention from Annette that the European Common Fisheries Policy is very much a science-based instrument. So I think there's a lot of science and science evidence that went into this. In many ways, I think that is a great exemplar of how we would like policy instrument to be developed. We can talk about the implementation power of that, but that's on a different page. But the policy itself has been developed, I think, in a very good way. It has actually been co-produced. I do remember when I went to a similar hearing maybe 6 or 8 years ago, where the Common Fisheries Policy was just about to be designed, when we were giving presentations, say that the European fisheries at that time policy was a disaster. I mean, if you look at the European ability, Europe is one of the best regions of the world in fishery sciences. We have ICES and groups like that who bring that together also for the region. Europe has the seas, the North Sea, the Baltic, but if you looked at the fish population and fish stocks and the health of them, they're in terrible state. So you think the science is there, the understanding is there, but somehow the action wasn't there. And I think out of that disaster, I might say, the Common Fisheries Policy was developed very much taking into account the scientific understanding of that. So I think there's a lot of positive elements, Michael, there that we're on the right track there. Having said that, I will say that I have seen some of the sciences that we've been also supporting here in Kiel by connecting the natural science with the economic science. I think that's Annette also pointed to that. If you take a resource economist point of view and looking at fisheries sciences, there's a couple of interesting lessons there. For example, a fish in the ocean has no economic value. That is not true for a cow on the field. A cow on the field has economic value before you slaughter it, right? So these fundamental economic ways how we look at the ocean space, which are just so different than our land-based economies. And I think it's these fundamental shifts that other countries have taken more into account. So there's, you know, you can get rights to fish stocks and things like that you've seen, for example, in fishery policies in Canada and also New Zealand. So I think there's, at the fundamental level, there's still a bit more work to do in the direction that Annette was pointing at too. But I will say that overall, the construction of that common fisheries policies was done much, much better than many other policy tools we have. And it was really science informed. But I will allow others to comment on the effectiveness of that policy. So there's one thing you put down the rules, and then there's the other thing, people actually go by the rules. So there's a few things to be desired. And I think the other element, Michael, that you also pointed to, do we have also the information around it that allows you to actually do a proper following on management? And I think this is where Mission Starfish comes in, observing systems come in. And as Annette pointed out, that is not just an observation system about the fish in the ocean or the pH, but it's also the social sciences, the economic sciences around it, impact, changing of behaviors. For example, you know, fisheries and the marine trade used to be the biggest economic sector, in particular fisheries of Europe. That has now been surpassed by the wind economy. This has a lot to do with jobs and growth. You know, one of the reasons why we were subsidizing fishing so heavily was because of jobs. But now you can say, well, maybe we can shift some of those jobs to renewables, and in that way relieving the fishery pressure. So I think there's interesting elements there where science is not yet fully utilized, but the common fisheries policy is not it's actually a good example of where this co-design between science and policy has actually worked quite well.
That's very interesting. It does emphasize the importance of the link between the science and the policy, and sometimes the policy has to recognize the science can't give you all the answers. Fisheries is certainly an area where science and politics interact. I wondered if Pierre Karlskin has any interesting comments on that dimension in the Committee on Fisheries.
Well, I must confess that I have to go to another place, so I am following the meeting with my my smartphone, but I hope you can hear me.
Oh, yes,
Of course, we have to be satisfied with the fact that the common fishery policy is one of the policies that is the most driven by science, and I think good science. But we also have to have in mind that science is not something that doesn't change. Science changes, and most of the concepts that are inside the common fishery policy have been developed at the end of the 20th century and the beginning of the 21st century. But don't forget that we did not understand everything as we do now on climate change or biodiversity loss, on the relationships between, and also in economics. I mean, there are still ongoing processes to elaborate better science. So that is why we shouldn't keep fully satisfied by this beautiful policy. I mean, we have to make it evolve, and that is really what I want us to do together, because the equations are not exactly no longer the same compared to 2030.
Thank you. And that underlines the importance of dialogue and continuing dialogue. Annette, is there anything further you wish to comment on that aspect?
Yes, on a couple of things that were said, very interesting things that were said. So maybe I will start with the question of can we learn from others? And indeed, I find that very, very important to touch also on this international cooperation topic, because of course, whatever we do in Europe, we are only managing a small part of the fisheries, and we only have a small part of the seas. So if we want anything meaningful to happen in terms of protecting the oceans and reacting to and mitigating climate change, we have to also build on the international cooperation. And so we do also have to learn, as Martin said, we do also have to learn from others who have maybe made more progress in implementing certain advanced approaches. I know that there is a discussion, for example, going on in NAFO always about the ecosystem-based approach, which is very important for us to be part of and to follow. And the study that I have been mentioning that we commissioned under our small science mechanism, indeed also it doesn't look across the borders of the EU, but it looks at the different member states and different practices in the EU to also see how can we learn from these kind of best practice examples, or at least good examples. Then I would like to mention the fact that indeed, I think also the implementation, of course, that's a very important point that Martin made. I mean, the implementation is, of course, crucial. We can have the best policy, but if it doesn't get implemented, then it is not going to bring the appropriate results. This is also something that the biodiversity strategy, and in particular the action plan that will be made under the biodiversity strategy, will really focus on, to look at where are we still lagging behind in the implementation of the good policies that are there, and where do we actually have to look at new policies. And maybe to touch on the last point, science changes. Yes, that is very true. Of course, we cannot say that the approaches and the mechanisms and the models that have been developed at some stage will be valid forever. I think we really have to, and I think, I mean, science is the best example of how that kind of goes naturally, to always develop and always also be ready to challenge ourselves, and also have, I think that is very important also for the policy making, to also have the stakeholders, both from the scientific side but also from the civic society side, challenge the policy, because that is how the policy gets better.
Thank you. Tor, do you have anything to add, or shall we move on to the next?
Yeah,
question?
I can maybe say something a little bit more general. It relates to this, but it goes more, maybe more to your general question. This resources not yet tapped into. We could think about it in this specific context, or more in general from the science-based knowledge. And this is the issue that several of you have already implied: the issue of translation, the translation to stakeholders, to public, the specific person. And you could say, to some extent, we kind of bypass it in our report, because we have a very science-based part. We use a language we normally use, hopefully accessible, but still it's temperature, it's meters, and so on. And then we go directly to the policy implications, which we kind of see ourselves. So it's the intermediate step there that we would be challenging to be even better in. And this also goes to how to use these things that are yet incomplete or partly incompatible in all the different fields of knowledge that we have on the biology, on the physics, and so on. And they would likely just involve probabilities going in to the future. And ICES, to a large extent, I think it's at the forefront there, to the extent that these things are being considered. But still, management, at least solid management, you could make the point that that is, to a large extent, looking into the observed past. So there is a challenge to get these things we think we kind of sort of know with probabilities for the next year, for the next 10 years, and so on, even more into the management, because management is, of course, about the future. We cannot change the past. And I know, for example, ICES have started to dig into this with a working group just recently. So this translation part, I think, is very fundamental to what we can contribute, but we cannot solve it ourselves being in our scientific box. Thanks.
Translation links directly with communication, and I just wondered if I could move to sea level rise, because unless you happen to be in Sweden or Finland, which is still rising, the rest of us are being faced by global sea level rise with big uncertainties over Antarctica, and as our report emphasised, some local variations on top of that, depending on the state of the Atlantic. And that guideline figure of 1 metre by 2100 is just a guideline. And there's still a lot of uncertainty over how fast that will be reached. And of course, in 2100, if it does reach 1 metre, it doesn't stop there. It doesn't sometimes plateau. And by 2200, it's still only 1 metre. It just continues going up. And this is particularly sensitive to Antarctica, and there was a new paper only 3 weeks ago which suggested that one of the key glaciers, the Pine Island Glacier, one that holds back the West Antarctic ice sheet, is fragmenting faster than expected. So all these trends are not reversible, but they're very long term. How do you communicate that to policymakers? How do you, or policymakers probably get it, but how do you communicate it to the public who have to agree the policy measures, whether that's expenditure on adaptation or drive a greater urgency on reducing emissions? That is one communication challenge none of us have a solution to, as far as I can see at the moment. But just taking sea level rise as an example, are there any ideas on that? Yeah, Martin? Yeah.
Michael, maybe I'll take a start on this. And I think the way you framed it is very important. On the one hand, we can first look at the root cause of problems, or where does sea level rise come from? I mean, relative sea level changes sort of relative to where we live, has a couple of different factors. One is, as you noted, the rebound from the last ice age. It's a very slow process, quite predictable, I should say, for the next 50 or 100 years. But I think the more recent one, that's the sort of climate anthropogenically induced one. And I think here, Michael, the point that you made is, as it comes to the source of the problem, that is not a regional source, right? So the big uncertainty in sea level rise also for Europe is, what is the future of the last large glaciers? In particular, we understand probably Greenland slightly better, although I will say there's always surprises still in Greenland. And Antarctica, because it has so much more ice volume, is sort of the big unknown. And as you rightly pointed out, science is not yet sure how high the risk is, how much additional sea level we could get from a runaway melt system in Antarctica. That is really cutting edge science. There's some papers that suggest it's going to be a real major issue. Others say maybe not so much. But this is something, but I think the point that I'm making here is, for European science advice mechanism, the threats might be far away, and the ocean is connecting us around the globe. So it is really an issue that speaks to the global cooperation that we all are benefiting from. So that's the one point. Now what you then mentioned, so what does it mean in a very practical sense? And the stakeholders, I know very few stakeholders who are actually interested in global mean sea level rise, because that is not really a stakeholder. Stakeholders are much more local. They would like to understand, how can I protect my country, my harbor, my installation, my business from sea level rise? So they're clamoring for the local information of sea level rise, and the scientists are always careful to say, whoa, the global numbers are pretty safe, even there's some uncertainty there. But then when you bring them down to the region, because the physics gets so complex, this is a much different story. So that's the first. So there's a bit more. So there's added uncertainty when you come to the local level. Michael, you mentioned some of them. On the other hand, the practicalities of it is, these policies inform engineering decisions. So they inform dike building, they inform, nature-based solutions, let's say regrowth of corals, sandbars, and the like. So the engineering community is more than used to uncertainties. That's their daily life, right? So in some sense, so you can actually communicate the scientific uncertainty to the engineering companies and come up with no regret strategies. And many of the European countries have thought about how they're going to deal with sea level rise from these sort of no regret strategies. So what is a no regret strategy? It says it will work if it's 0.5 meter, it will also work if it's 1.20 meters, and it's still the economically best solution in between, or something we can more easily react to as we go. So this is, I think, where the science policy engineering is working in practice. And I think so it is informed by academic science, but it's actually executed by engineering science. And I think these connectivities are the ones that we need to make really efficient policies and to make really efficient projects. And I'm very grateful for the mission Starfish that we just heard about, that really takes that mission approach that says we want to solve a problem. So we really need to connect through the academic knowledge down to write the practical knowledge that we need on the engineering and intervention side. And I think that is a great challenge for all of us, also in the academies, to really take that on fully and to take our academic knowledge and the advances of it, but also make them available through the engineering science for practical applications. And both the mission Starfish and the UN Decade are really calling that gap out, as Tor was saying. Thank you.
Good, thank you. I'd like to get one more question in before we run out of time. Are there any quick comments from the panelists on this issue, or shall we move on?
If I may, because this is the big challenge, yeah? Both the climate system and political processes and so on, they are slow. And I think we can get even more impact focusing on, say, the glaciers here in Europe. 1/3 of them are already committed to melting. It just takes time to melt all this ice. So in present climate, 1/3 of this will go to the ocean, but it takes another 10, 20 years. In Austria, not being concerned about sea level, but just seeing their glaciers disappear, they are very well aware of it. I think that was actually the country, the issuing of a report 1.5 or 2 weeks ago was mostly noted, because they can see it from their side. And I think playing more on this can maybe be a way to get even more attention and more realization of the inertia thing, the commitment we already put into it. There's 2/3 left of the glaciers to save, but 1/3 is already on the way to the ocean.
Yeah. Annette, did you have something to add?
Yes, I will try to be very brief. I would like to take up on the comment about the basically communication of the scientific results to also the public and the stakeholders. And I think one actually very good example of how a topic that many people are really interested in can be used was the recent seagoing expedition, the Mosaic, that went to the Arctic to do research there, and of which also we funded a part about understanding the Arctic ecosystems, because that has, I think, had a very big also public response, and they've also done, I think, from this project a very good publicity approach. It was on the TV, at least in Germany, in a long feature, and it's really, I think, a topic that people respond to very strongly, and of course in which when we look at the Arctic, so many of these processes that we have just discussed and that are in the report are so clear to be seen. So I think that is one point that I have, that it's also important to use the right way to communicate the science. But I also think that I think we shouldn't be afraid also to be differentiated in the messages. I think we should not think that whenever we talk to the public or to the stakeholders, we have to make things as simple as possible. Really, people are able to deal with complexity, and I think sometimes it's really important to also underline the complexity. Very often there is no easy solution that will really solve it for everyone. We have to find compromises. We have to find approaches that work rather than approaches that are perfect. And I think that's also an important message.
Thank you very much. We have actually have someone monitoring the Q&A and the chat. So I wonder if I can ask Johanna if there's any question that's been rising in popularity or support that we should have one final attempt at answering.
Yes, so there were actually quite a few questions coming in, and I see that Martin is already taking the time to answer one of them in writing. I don't know, Martin, are you almost done, or would you like to take this and answer it just now?
We only have time for one question, so is that the most important on your list?
I think it's an interesting one because it relates to the renewable energies. So maybe I can just read this out quickly. It's more of a comment, but maybe, Martin, if you could comment again. So Jan Kappel wrote, concerning reserving space to renewable energy production and thereby decreasing the fishing pressure. Fishing pressure by and large won't decrease for that reason alone, but tend to increase outside closed areas if not other tools are put to effect, for example, cats in the fleet. So Martin, if you could just quickly comment.
Absolutely, Johanna. Thanks for picking that out. And thank you, Jan, for raising the question. I think it speaks to a point that is very important to me. And that is what this report alludes to. We mentioned it as a recommendation, but a proper way to dealing with the ocean in the future is to really understand it as space, as we do on land. So that means to imply some type of zoning activities. We sometimes call it marine spatial planning or ecosystem-based management. There's different technical terms, but at the end of the day, you have a certain amount of volume actually of the ocean, or square meters, whatever you want to use. And what you have to do, you have to plan for that and say, this part is where we're going to do renewable energy. This part is where we're going to do restoration zones. This is part where we're going to allow for fishing and then transport and the like. And these are tough negotiations, and they should be done just as professionally as we do them on land. Any of you who have tried to build a home, a company, or expand your agricultural production know about the zoning issues. And that type of zoning in the ocean is starting to emerge. There's actually some European policies requesting member states to do that, but it's not done globally very well. It's not always very harmonized, but it's exactly that, because we have conflict issue of the use of the ocean, and the demands for that space is going to go up, not down. So it really behooves us to think about a proper space-based management approach, and that should be science informed. So again, academies have a role there, but it needs to be executed by the regulator, so it's the government's kind of job. But I do think that is the most productive area to collectively work on. How can we most effectively use the ocean volume or ocean space for the various types of uses? And quite often we see by the more sectorial approach some odd things that happen in the other sector where you really don't come up with a very sustainable solution by zoning for one purpose only and forgetting the other uses. And we have seen many perverse incentives and wrong areas here. So it's a very good question, Jan. So my answer is proper, open, multi-stakeholder, science-informed spatial planning of the ocean is the answer to that problem. Thank you.
Thank you. Well, I think we're almost out of time. I just offer the chance for one final statement or short comment from any of the panelists that you think you would like to leave us with.
if I may, I think I have very little to add to what Martin said in his last intervention. I mean, that really, I think, summed it up very well in terms of the use of the ocean space. And especially, I would like to emphasize the need for a indeed involvement of all the stakeholders that have a role here. I mentioned it briefly also for the MPAs, which is of course also kind of a part of this whole discussion. We've also looked recently in a study at the interactions between offshore wind installations and the impacts on fisheries. So indeed, I think this is going to become even more important as we start to understand, how much competition there actually is for the use of the oceans, or at least for particular parts of the oceans. Thank you.
Thank you. Tor, do you have anything final to say?
Yeah, I just repeat my previous point that any management legislation or investments, we know it, of course, but sometimes it's good just to state it. It's fundamentally about the future. And the more informed we can be, the more we actually can implement, even in a natural science way, to go more, how to say, predictable into it, the better. But of course, you shouldn't trust it more than probabilities. But still, I think it's sometimes just to repeat that for oneself can be very useful. We cannot change the past.
Thank you. And Martin?
Well, I think it was a great discussion. I think it really shows when the academies come together and really tackle an issue and issue a report like we've done. I think it raises a number of really interesting policy issues. And I really want to say, I think for me, the summary of this consultation here, but also of our seminar here, is really closing this gap from the academic knowledge to those who are in the practical areas like Annette, trying to make things happen. And I think that is the area that is so productive to work on together. And I think it's a great area for early career scientists to get training into. We'll need more of that. So I'm quite looking forward to that. And I'm kind of happy that our report here really spurred that point. And as Tor said, looking to the future, thinking of better ways to really think about how to interact between the ocean and humans. That's what it's all about. Very exciting. Thank you very much.
Thank you. I think Pierre Kalskin must have moved on to his next part, so I don't hear from him. So anyway, I will pass over from Tokyo, which is where I am, back to the Netherlands, which is where Wim is, thanks to the translocatability of Zoom. And thank you all for your very productive discussions.
Thank you.
Thank you, Mike. Thanks very much. And thanks to all the panel members. I'll keep it very short. I would like to thank, first of all, the members of the working group, and in particular, of course, the chair, Tor, for this wonderful work and for the contribution to this discussion, and also Martin for being here with us. And in particular, I would like to thank both of our external members, the panel members, in particular, Annette Horelman, who's still here online, but also our Member of Parliament, Pierre Kalskin, for joining in this discussion. It is clear that this is it's not just the beginning. This is an issue that has been with us for a long time, but it's clear that the EASAC report is making an important contribution to the discussions in this very complex issue, which will be with us for decades to come. And as usual, the EASAC reports have a long time impact. And I do hope that this is in a way the beginning of a renewed discussion about these issues. And I'm sure that the members of the working group and also Mike will be willing to be involved in further discussions about this, not just only at the European level, but also for those the participants who are eager to organize a meeting in their home country. People from the working group and EASAC are always happy to join and add to the discussion. I also would like to thank the members of the EASAC Bureau and the Secretariat for organizing this wonderful meeting. And I hope to see you all back soon at one of the other meetings of EASAC for the other reports. A lot is coming out these days. And we also, and with Annette Horelman here on board, I would like to add that we're very happy with the increased ambition of Europe in every respect, also in the renewable energy area, and the awareness that is present there in Brussels on the danger of the climate changes. Thank you very much all for listening. Thank you for being with us, and I hope to see you back in the near future.
Thank you.